Hello, welcome to Astronautics for Exploits. This is Dr. Ayenshola Ogundele. Space gas stations missions and technology demonstrations endeavor to turn space gas station science fiction into reality. The focus points are as follows: space gas stations technology and space gas stations approaches and technology demonstrations. For several decades, space missions to unravel the mystery of the universe and to enhance humans' quality of life on the Earth and in the space have been invested into. These missions had been majorly launched from the Earth. Based on the Earth's gravitational pull, it is very costly to get into the orbit. Rockets launched from the Earth must carry the fuel needed to get to their respective destinations. To ease space transportation, efforts are being channeled towards developing space gas stations missions that will help the establishment of space gas stations. Over the years, various space gas stations approaches and technology demonstrations have been put forward. Examples are Orbital Propellant Depot of 1970 concept, Orbital Propellant Depot Space Transportation System of 1971, and Evolved Propellant Depot concept, Astroscale Prototype Servicer for Refueling, Spacecraft-to-Spacecraft Fuel Transfer Depot, and a host of others. The 1970 Orbital Propellant Depot concept involves a nuclear shuttle docked to an orbital propellant depot and a space shuttle. The nuclear shuttle, in either manned or unmanned mode, will deliver payloads to lunar orbit or other destinations, then return to Earth orbit for refueling and additional missions. An evolved propellant depot is another proposed concept. It involves starting with liquid oxygen, the heaviest propellant, adding liquid hydrogen or hydrocarbons later to increase performance. Depots could be increased in size, adding more things or more fuel as needed. Space gas stations technology. Based on renewed interest on space gas stations, investors are infusing capital into the venture, and space companies are developing strategies and technologies that will aid actualization of the establishment of gas stations and refueling infrastructure in space. Orbit Fab is one of the space companies making strides toward turning the concept of a gas station in space into a reality. An artist's impression of a rocket destined for a journey beyond low Earth orbit being refueled at the space depot designed by Boeing is shown in this picture. Space gas stations approaches and technology demonstrations. There are various approaches and technology demonstrations, and examples are Orbital Propellant Depot of 1970 concept, Orbital Propellant Depot Space Transportation System of 1971, and a four propellant depot concept, Astroscale Prototype Servicer for Refueling, Starship Propellant Transfer Gas Station Depot, Spacecraft-to-Spacecraft Fuel Transfer Depot, Simple Depot Cryogenic Concept, Refueling Architecture for Very Low Earth Orbit Missions, and Operational Flexibility and Asset Retasking enabled by in-space refueling. In 1990, NASA proposed a propellant depot concept. The concept involves a nuclear shuttle docked to an orbital propellant depot and a space shuttle. As envisioned, the nuclear shuttle, in either manned or unmanned mode, would deliver payloads to lunar orbit or other destinations, then return to Earth orbit for refueling and additional missions. NASA concept for a propellant depot from 1970 is shown in this picture. In the NASA's Orbital Propellant Depot of 1971 concept, an Earth-to-orbit fuel tanker approaches the Orbital Propellant Depot. The concept involves an orbital modular propellant storage depot supplied periodically by the Space Shuttle or Earth-to-orbit fuel tankers, critical in making available large amounts of fuel to various orbital vehicles and spacecraft. Illustration of NASA concept of 1971 for orbital propellant depot is shown in this picture. An evolved propellant depot is another proposed concept. It involves starting with liquid oxygen, The APS propellant, adding liquid hydrogen or hydrocarbons later to increase performance. Depots could be increased in size, adding more things or more fuel as needed. Artist's concept of a proposed United Launch Alliance propellant depot with some sheet is shown in this picture. Once a lunar in-situ resource utilization processor has been developed, a depot could be built at one of the Earth's Moon Lagrange points. Propellant could be supplied from the Moon at a significant reduction in performance. Illustration of an evolved propellant depot concept is shown in this picture. Astroscale, a leading provider of on-orbit services and logistics across all orbits, has been awarded a contract to design and deliver a satellite to refuel other compatible satellites in space. The launch-ready Astroscale Prototype Servicer for refueling is scheduled to be delivered in 2026. Astroscale Prototype Servicer for refueling concept of operation is shown in this picture. The Astroscale Prototype Servicer will carry and transfer hydrogen to its clean spacecraft, rather than the client having to maneuver to a fuel depot, allowing client operations to continue uninterrupted. The mission is designed as a standard class satellite to conduct multiple refueling missions in geostationary Earth orbit. Astroscale Prototype Servicer for refueling is shown in this picture. Starship Propellant Transfer Gas Station Depot is another approach that is being worked on. NASA awarded SpaceX for research and development of project of managing cryogenic propellant in space. The project is aimed at demonstrating a large-scale cryogenic propellant transfer demonstration in orbit with Starship. Presently, SpaceX has begun work on Starship orbital propellant transfer test for NASA. Illustration of SpaceX Starship orbiting the Moon is shown in this picture. For Starship to be a truly revolutionary rocket, the SpaceX is trying to master rapid reusability and orbital refueling. With full refueling in LEO, Starship is becoming capable of delivering dozens to many tons of cargo and passengers to the surface of Mars. SpaceX Starship refueling proposed approach is shown in this picture. In the absence of gravity, propellant transfer is more difficult, since liquids can float away from the inlet. In 2007, as part of the Orbital Express mission, Spacecraft-to-Spacecraft Fluid Transfer Depot concept was being proposed, and it was successfully transferred between two single-purpose design technology demonstration spacecraft. The Boeing servicing spacecraft has to transfer propellant to the Ball Aerospace serviceable client. Orbital Express major subsystem contractors are shown in this picture. Simple depot cryogenic PTSD, propellant transfer and storage demonstration, is also another example of the approach. It is a long-time in space cryogenic propellant storage demonstration. It is an automated rendersal and docking, and multiple cryogenic propellant transfer demonstration. The mission lasted for at least 1 year, and the goal was simple depot potential platform. Artist's concept of a robot servicer using propellant transfer technologies to extend the life of orbiting satellites is shown in this picture. Refueling architecture for very low Earth orbit missions offer potential for Earth imaging performance and other new applications. Its major drawback is the high level of dry that quickly degrade satellite orbits, requiring larger amounts of fuel or extremely frequent satellite replacements to maintain nominal operations. Artist's concept of orbit fab in-space hydrazine refueling service is shown in this picture. Umpire modeling for very low Earth orbit is based on the perturbation forces, such as differential drag and J2. Tankers are sized to be able to successfully refuel all clean spacecraft in 1 to 2 planes. Specific tanker constellation architectures and refueling concepts are developed based on customer constellation architecture. In-orbit demonstration of satellite refueling is shown in this picture. Preliminary results of umpire modeling for very low Earth orbit mission scenario indicate that it is feasible to develop a tanker constellation architecture that can serve the refueling needs of typical very low Earth orbit missions. For a typical very low Earth orbit mission with spacecraft expanding their fuel supplies approximately every 2 years, it is possible to select from a range of tanker orbits that achieve right ascension of ascending node alignment within time constraints. The mission robotic vehicle developed by Northrop Grumman is shown in this picture. Across several different orbital regimes and markets, operational flexibility and retasking is unlocking large value propositions. Orbit 5 Umpire is allowing tremendous flexibility and configurability to address trade studies of variable complexity. Illustration of an Orbit 5 spacecraft grabbing space junk in orbit is shown in this picture. For more information, contact Astronautics for Exploits. You've been listening to Space Gas Station's Missions and Technology Demonstrations presentation, an endeavor to turn space gas station science fiction into reality, presented by Dr. Anishola Ogundele, with the focus point Space Gas Stations Technology and Space Gas Station Approaches and Technology Demonstrations. Thank you.